Hello there, it's Prodeye, and in this video we're going to go through how information is represented in electronics. So we're going to start with counting in base 10. This topic is extremely simple, so I'm going to start by explaining that. Base 10 is really just the name for the number system that humans are confident in counting in. The reason that the name given to it was base 10 is because there are 10 different symbols for every value up from 0 to 9 before you have to repeat symbols. The 10 symbols are 0, 1, 2, 3, etc. all the way up to 9. An example of a symbol repeating itself might be 14. The reason is we've already used up our 10 symbols and then we're going to have to repeat symbols 1 and 4. This may not make a lot of sense, but in the next PowerPoint, in the next slide, I'll show you how it's done. So we can make an analogy here. Let's imagine we have a 10-sided die. There are only 10 possible outcomes before we need another die. With a pair of 10-sided dice, we can get 10 outcomes from one die and 10 from the other. This is like repeating numbers because we can have 0 to 9 on one die while changing the other die whenever we get to 9. So the sequence should end up looking something like this. We can have 0 on the first die and get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 combinations that we can have with 0 on the first die. And then we can roll a 1 on the first die. And then on the second die, we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 18 possible outcomes. We can have 0 on the first and 1 on the first, or 1 on the first. And we can have 0 to 9 on the second. So the amount that you can have on the first times the amount that you can have on the second is the total amount of combinations that you can have if you have two 10-sided die. So 10 times 10 is 100. Let's imagine a similar scenario, but this time we don't have access to 10-sided pairs of dice. It's more like real life this time, where we have a selection of coins, but we need to come up with a similar number system. We need to be able to represent numbers in some way. Our new number system we're going to call base 2. The reason we'll call it base 2 is because we can have combinations of coins, but they only have 2 combinations per every coin, being a coin can land heads face up or tails face up. Those 2 possible outcomes come from when you have one single coin, but if you introduce another coin, like we did with the example with the dice, if we have 2 coins, then we can have 4 possible outcomes. We can have heads on one and heads on the other. We can have heads and then tails. We can have tails on one and then heads on the other, or both of them can be tails. Those are 4 different outcomes that you can get with just 2 coins. If we introduce one more coin and we end up with 3 coins, then we can make 8 numbers. Note there, I said numbers instead of outcomes. The reason I did that is because with every combination we can assign a number. A computer can understand, it can distinguish between different combinations of heads and tails, and it will call them numbers in general. That's how it will process that information. So that number system has another name, binary. This is what computers use to communicate and really do anything that they can do. Binary uses the same coin analogy, but instead of heads and tails on a coin, a wire can switch between 2 states. A wire has voltage or no voltage. It works the same because we can introduce more wires to gain more than 2 outcomes. That is, if we have one wire, we can have an on or an off. If we have 2 wires, we can have an off-off, a off-on, an on-off, or an on-on. 4 different outcomes. In real life, these wires don't actually use voltage and no voltage. They actually use different measures of voltage, which could be something like 0.5 volts versus 1 volt. I'm not entirely sure what it was, but it's not on and off, although it's usually just easier to refer to them as on and off. So we're pretty much done here. Overall, what we did was we learnt the language that computers use to function. We thought about our own number system in a bit of a different way. Some computers don't actually use binary. They can use base 10, but The idea is that they can use more than just two voltage measures. These kind of computers are known as analog computers, and they function in systems like hexadecimal, or I don't actually know anymore. Hexadecimal is the main one there. In our simulation, Minecraft, hexadecimal it's really useful, but I don't know if I'll be able to do it. Not many people can do it. It's one of the most difficult things to work with in Minecraft, is hexadecimal. It's a lot worse than working in binary, which is what I'm going to try and stick to in this series. I'm going to try and stick to working in base 2 and use digital electronics. Next time we meet, I might discuss hexadecimal, or I might just move straight on to explaining logic gates. It really depends on how I'm feeling, whether I'm up to a challenge and going to talk about hexadecimal, or whether I'm just going to continue on digital computing, which is, I suppose, what this series is meant to be about. So, I hope you've enjoyed, but more importantly, I hope you learned.